Hi everybody, today we are going to talk about the assumption of the simple linear regression model. We are going to start with some intuition, then I want to provide some example associated with the assumptions of classical linear regression model, namely its linearity and the constant variance. More details for each assumption we will discuss in different video. Let's go. The first assumptions, the model is the linear in parameters beta and correctly specified. What does mean it's the byword? It's the linear in parameter. It's linear in two sense. It's linear in parameters and it's linear in variables. By assumption, it has to be the linear to parameters, not necessarily in variables. Let's see some example here. In example, yi is equal to beta 0 plus beta 1 xi plus error term. Here our parameter is beta 0, beta 1. And we can see that obviously it's linear in parameters. And x, this is my variables. The variable, we see that it's linear in variables also. Here, it's fine, it's the both condition. It's linear in parameters and it's linear in variables. In our example 2, let's see that the yi is equal to beta 0 plus beta 1 x square xi square plus error term I. My parameter beta 0 and beta 1 x square variables is not linear in variables. But generally, it has to be the linear in parameter, not necessarily in variables. Let's see one more example. yi is equal to beta 0 plus ln beta 1 xi plus error term I. Here my parameter beta 0 ln beta 1 I. Since my slope ln beta 1, this one is not linear in parameter. However, it's linear in variables. For us, they have to be the linear in parameters. Since this one is not linear in parameters, we consider this is the violating assumptions one, which have to be the linear in parameters. And second assumption, variability of the x. What does mean it? Since we know that the x is fixed variable, and there should be the variability, there's some variation among my cross section of x. Suppose it's example x, I have this x1, x2, x3, and if they should have some variation, it shouldn't be the same x bar. If suppose that the x1 is equal to x bar, x2 equal to x bar, x3 equal to x bar, and there is no variation between my across my cross sections. When I take the average, then I calculate this one, they become in my zero expected. When I'm calculating the variance, x1 is equal to x bar, and when calculating the variance, they become in the zero. In this case, I cannot able to calculate my beta. I cannot estimate my beta. So we should make the assumptions. There should be variability on x, variability of the x. Next assumptions is the error term should be the homoscedastic, or we call this one is the variance of the error term. I should be equal to sigma square. Is the variance is the constant. If we draw the graph, y and the x, y is my frequency, and x1, x2, x3, the conditional distribution on my axis. And I will calculate from this my actual value to my expected value of y conditional to x, means to my mean. This one they will give me my the error term for error term 1, the error term 2, error term 3, error term 4, 5, the 6. And we can notice here the distance between my mean and my actual value. The distance will be the same distance. This one we calling variance is the constant. Here I can write here the variance. If we calculate in the variance, the variance of my error 1 is equal to the variance of error 2, the same is equal to variance 6, error term 6, and this one all equal to, we call it the sigma squared. Error, sigma of the error square, all of them is equal. 1, 2, 3 is equal. Let's see that's the one more example. We draw that's the graph here. If we draw that's the graph, how it looks if is not constant, the variance. Here there is the example. X. This is one example here. X1, this is my X2. Here we can see that's the variance 3, 4. Here we can write here for this example, we can see the variance is not equal. The variance of my U1 is not equal to my variance of my error term 4. We can see in the graph also, when we calculating also, we can see these two variance is not equal. That time we can conclude the variance is not constant and they violating the assumptions 3. Here we can see that the y values are spread around their mean values with the same variance, and some of them is the positive, some here is the negative. When we will sum all of that's the error terms, the sum factors in error term have positive, some have the negative impact on this my y. Since if we will collect all of this one, they will give me that's here the next assumption, expected value of my error term is 0. Expected value of error is the 0, means that on average error term has no effect on y. I can write somewhere here there is these assumptions. Expected value, since this one is constant, we can make the conclusion error term when we make in summation on average it will be the 0. Homo means equal, hetero, we call it this one is heterocadastic. Hetero means it's the not equal. The next assumptions, the disturbance term have independent distributions. The covariance of the ui and uj is equal to 0 for I not equal to j. This refers to the assumption that's the no autocorrelation between my samples. There is no autocorrelation between my sample. Here, if this one is equal to this one, we can write here the joint distribution of the ui, uj. We can write this is independent. Ui multiplied by expected value of the uj. This means it's the sample is the random and there is no autocorrelation. There is no relation between the U and J. U and J is independent. And the last, the disturbance term has normally distributions. And these distributions, we can see it here from our assumptions. The error term I distributed between normally distributed, between, this is the mean in the assumptions for mean 0, and here sigma square my error term. And we can make this the conclusion. If assumption 1, 2, 3, 4, 5 they holds this 5 assumptions, we can conclude that OLS estimator of the coefficient are blue. Under assumptions from its 1 to 6, we conclude that OLS estimators of the coefficients are blue. B here referring to this the best OLS means they refer to the best to OLS. L refers to linear in parameters. U refers to unbiased. E refers to estimator. That's all for today. Thanks for watching my video.